Hey everybody, welcome to the Build Show. I'm standing down here in the basement. You think we're talking about basements, but no way. What are we talking about today? We're going to talk about floor framing, right? We got a bunch of little nitty-gritty things happening here with the floor frame. I thought it'd be a great opportunity to explain a bunch of the different options that we went with here. We can talk about some beams, etc., engineered floor joist, but let's get into it. So you can see here as I look up, we have your typical engineered floor joist. So these are a solid cord, bottom cord, top cord. It has an OSB web, which stands for oriented strand board, right? You can see that there. These are 14 inches deep, and these are 16 inches on center here. Now, we had the ability to go to 16 inches on center here because, like a typical house, we have a center carrying beam, right? So if you come over here and take a quick peek, you notice that we have these 3 LVLs here. This is what I call a flush beam, where the bottom of the beam is flush with the LVL or the engineered floor joist. So it's one continuous ceiling here. But because we introduced this beam, we're able to keep this spacing out at that 16 inches. Now, one of the requirements here, because we're going to get into something here that's more exotic in the frame, but keep in mind, one of the parameters of this build was we were limited to the height of the building. So we had to squash some of the components. So instead of easing the framing and say doing a 16 or 18 inch floor joist, we had to stay down in that 14 inch realm and find a different way to use them to keep this. We're literally playing with inches on this house. So 16 inch, this is our flush beam condition. We're going to take a walk around here. We're going to talk about the next condition. As we come around here, you'll notice the beams here are actually doubled up. We don't have that center beam helping us through the middle of this. So these floor joists basically fly 24 feet across the house. And the way to solve for that was that we simply double them up. So where we would have a standard single floor joist on 16 inches, here we have a double floor joist on 16 inches. So we get that added length, but we had to provide double the floor joist to pick up that load and handle it. If we move over into this space, you'll notice here we have even a third condition in the floor. So this is a little bit narrower. So we didn't have to go to the double floor joist. We could stay to the single floor joist. But notice here, we went from the 16 inch on center down to the 12 inches on center. So when it deals with flooring and floor framing, you have a number of options to gain strength. You have your traditional floor, that is floor joist on 16 inches on center. The easiest way to make that a stronger floor or a longer floor is to increase the depth. And that is also the most efficient way to do it, to simply increase the depth. But again, we were struggling here with the height, so we had to play with that solution laterally rather than a vertical solution. So moving in from that standard engineered floor joist at 16 inches on center, we're able to go down to 12 inches on center. So that means in any 4-foot piece of floor sheathing, instead of 3 joists, you have 4 joists carrying it. So you get that added 25% of power there. Or, as we spoke of here, you can go to that double floor joist on 16 inches on center and basically get 6 floor joists per 4 feet. So we get that increased strength by adding those extra floor joists there. We're going to jump over. We'll look at the framing plans for this. We'll have a little further discussion on this point. Join me in a bit. Hey everybody. So we're back at the drafting studio. We just took a little walk around the job site. We talked about floor framing, different capacities. We're very fortunate that in this house, very close together there, we had a number of different floor framing packages. So we're back here at the drafting table. This is a small section of the floor framing plan for there. But if you notice, got my friend Big Red here. This is the area where we are standing in and looking up at those various floor joists here. So let's talk about what we're looking at here. We talked about that flush beam here. that goes across here and gets picked up by that beam in a column there. But the important thing to note here for the floor framing is that our floor basically goes from here to there. But because we have that floor beam inside, or running down the middle, then the span actually gets cut into two pieces, right? So we have basically two legs. Well, what does that mean? It means that these floor joists don't necessarily have to work that hard because they're bringing load into that beam is bringing load over to the column and taking it down into the foundation. So these were those floor joists that we used the 14-inch floor joist, and these were on those 16 inches on center, right? So pretty easy for those to do. Actually, those are probably oversized for what the span is here, but when we lay out floor framing plans, the depth is usually governed by what's the hardest working member, not the easiest working member. So even though these are easier working, we have to stay with that 14-inch because we can't go changing the depth of our floor frame. So we figure out what the worst case condition is and work up from there. The other small reminder as we jump into these that are a little bit more restrictive was that this building is in a place where the height of the building played an actual role in permitting and a whole bunch of things happening there. It's on the coast, so we had a bunch of restrictions implied on us. So we're literally, even though the building, you're talking 35 feet, 32 feet, etc., in the height of the building, we're literally playing with inches trying to fit this building in there. So the 14-inch floor joist kind of, again, was the one that maximized our structural integrity while minimizing the vertical height of the building as much as we could in the floor joist. So jumping on the other side of the fireplace, you'll see here, there's some floor framing. All right, so this is what a fireplace looks like in plan. You'll see there's the fireplace here. Downstairs in the lower level, we actually have a firebox being viewed from this section of the basement over there. This side will get just a wall. And we have this one large room here. Well, because we wanted this one large recreational room, you'll notice that the double span here now becomes a single span, and it goes from there all the way to there. So literally the span got doubled. So what does that mean? Well, in the case here, and I don't think it's quite this linear, it just seemed to work out this way, but we still maintained those 16 inches on center. But what we were forced to do is we were forced to double up each of the floor joists. Basically just put one alongside the next one. Again, the strength and span determines, right, the structural integrity and the requirements of what's happening there. So like I said, it's not quite that simple, but as a rule of thumb, if this is twice the span of this, then we need twice the amount of workhorses for it, right? So in this case here, the solution was to simply just put a second joist along them, maintain that 16-inch floor span. One of the other side notes of what's happening over here is you notice that we call for these little pieces to traverse the system. Well, we call that solid blocking. And what it basically does is these beams go from here to here. So you have some kind of support and a support there, and then you put a beam across it. Well, that beam wants to bend, right? That's the biggest failure mode along with shear, but when the load gets applied to that beam, it wants to bend. So one of the ways that we can aid those members in bending is to share some of that load laterally with the other floor joists. So if I didn't put that blocking in, what we would have is we would have a very simple one-way system, right? You imply a load, the beam tries to hold it up, and if not, it forces to bend. But because on top of that beam, we put a small diaphragm, which is the subfloor, and then we introduce some blocking here. Well, what that really does is that when I apply a load to these two floor joists, this blocking helps move that load laterally. Now, the further I get away from that load, the less help I get. But it's safe to say that if I was standing there, then all of this is kind of help carrying the load instead of just that floor joist. So that solid blocking really takes that one-way system and turns it into a two-way system, because it takes some of that load and it shares it laterally with some of the other floor joists. And when those get glued and screwed together with that diaphragm, you really have this kind of series of T's that are all connected together, and then you have that solid blocking in here, and that turns it into that two-way system. So it's just a way to kind of maximize the efforts of these floor joists so that we don't get that maximum bending down the middle there. We can get some help from our neighbors when that load gets applied. So to recap, we have a dual span here, 16 inches on center. They were single joist. We came over here, the span doubled. We went to a double joist, but maintained the 16 inches on center. Well, if you remember from when we were out at the job site, we came out here, and again, we have a span. Now, this span isn't quite as long as this one, right? So we could have doubled that up, but the better use of material here was to go to 12-inch centers. So what does that mean? It means that if I look at these three systems, in any 4-foot section here, I have 3 floor joists. In any 4-foot section here, I have 6, put 4. And then in any 4-foot section here, I have 4. So you can see that if we were strictly just buying these floor joists and they were all the same, then, I'm sorry, this is 3, not 4, 3. 3 at 16 inches on center, correct me. I was like, why is that compared? All right, so 3, 4, and 6. And so they're all doing the similar amount of work, because the load that's being imposed on these really isn't any different from here to there to there. The spans change, so that governs some other decisions to be made. Maintaining that 16 inch on center means that we get to use the least amount of material, which is reasonable because these joists are doing the least amount of work. Over here, in that 4-foot section, we have 6 floor joists, but that's because this is the longest span and we doubled them up, and these joists are doing the hardest amount of work, right? And then these here, we moved down to 12-inch centers, but kept them as single joists because this span here isn't quite as long as that. So it enabled us to move to that 4 inches. So you can see here that, you know, we have, just by changing the spacing, we've been able to manipulate the structural integrity of the floor system while maintaining that 14-inch floor depth across this floor frame. Now, we can, you know, in a later video, maybe we can get into, and we'll talk about some other variables when it comes to I-joists, so that just because these are 14-inch, there's probably, you know, a series of 3 or 4 different I-joists that all fall in that 14-inch, but have different strengths based on different characteristics of the floor joist. So also what they're made out of, different companies, etc. So there's a bunch of other things that can play a role there also. And if we had the luxury of changing the height, then it could have been something as simple as these went to singles because we were able to go to a 16 or 18-inch floor joist. But for the sake of this project, I think this is a really good example of just how do you manipulate that floor frame to serve certain conditions within that house. And again, we were very fortunate that right in this area here, we were able to get these 3 different floor systems. But before we go, I just want to point out one last thing here that I like to do. So framing plans and plans in general are basically a graphic conversation between myself as the architect and the builder, in this case, Brian. So Brian and I, even though we don't talk every day, although it's close to it, but this is our conversation that we have every day. So I take my thoughts, I put them on paper, And then Brian interprets those thoughts and builds a building, right? That's how things get built. So, but along that way, we have a lot of coordination effort, and there's a lot of people that have to play a role, and there's a lot of things that Brian has to worry about. So not only does Brian have to worry about putting up the building and making sure it stands like I do, right? There's a coordination effort that's pretty involved for Brian as mechanical equipment, plumbing, electrical, all of these things then have to fit nice and neatly inside this package. And because nobody wants to see plumbing pipes running across the ceiling of their living room, right? So all these things have to be hidden. Well, one of the common problems with floor framing is that you can imagine you go upstairs and all of a sudden there's a toilet, and the toilet is centered on a floor joist, and the drain is sitting right on top of the floor joist. Well, the framers put these in, and the really good framers will do a quick double check, but a lot of times, sometimes these things get missed, and you get this framed, and then the plumber comes out there, he takes his measurement, starts cutting a hole, and realizes, hey, I'm right on top of this floor joist. So how do we maximize that coordination effort? Well, at the drafting table, I can do things like grab all of the toilets and sinks and showers, superimpose them on the framing plan. You can see here that I changed them to red. So we have the toilet here, and there's the toilet drain. You can see it clearly misses that floor joist. We have another toilet here from the floor above. There's that toilet drain. And you have to know what toilets you're using because they have centers there. Sometimes they're 10, but for the most part, I believe they're 12 inches if they're wall-hung toilets. They vary a little. I dashed in the sink here, but you can see the drain there falls on it, but that really doesn't matter as much because you can manipulate, you have the trap in the bottom of the sink going into the floor, so we can manipulate that trap and get that to move. But the toilet it's the largest pipe in the house, and it's fixed. Where it touches the floor is where it goes through the floor. You don't have really the ability to move it. There are small suggestive tactics that you can move that over a half inch or so. But if it falls directly on top of the floor joist, then you have to come in and do some remediation to the floor joist, or be allowed to move the toilet, which in a lot of cases, these days, there's so many things coordinating with the toilet that it's easier to go back in and do the framing. But the reality is we like to try and capture all of this down here. And you can see here, this shaded area here is actually a shower. And the reason it's shaded is that shower gets dropped down into the floor framing. So we basically frame this like a giant hole, drop the floor framing in and sheath it down there. Now the reason for that is when you see those pretty pictures of people having these showers with no thresholds where just basically the floor goes right into the shower. Well, there's a whole bunch of things that need to happen here, like the sloped shower pan, the drain, etc. So we need to make up for a couple inches there to maintain that nice flush condition. So we have to drop that down in the floor, build it up to the floor level with the tile and shower pan and all of those things. But you can see that one clearly misses there. The two toilets clearly miss here. So I like to superimpose that stuff on there so the framer and, more importantly, Brian and the plumber know, okay, if based on the plans, we should be missing that floor joist, and we should be missing that floor joist, and we should be missing the joist in there. So just a small little coordination effort. As an architect, I think it's extremely important to understand that it's not a solo job where I do a set of drawings, turn those over to the builder and say, hey, have at it, good luck. It's more about, this is a giant team effort, and how do we make that happen? So anyways, I want to thank you for joining us here today. That's Building 101 on floor framing. And maybe in a future video, we'll get into this a little deeper. But until then, look for me on the Build Show Network. I have a number of videos out there. Hopefully we're throwing out some good content. Throw out a big shout out to my colleagues on the Build Show Network. We got Matt doing some fantastic work down in Texas. We got Jake down in Missouri doing some fantastic work. I actually have the privilege of doing some projects with him. We have my good friend Wade up here in Rhode Island, just doing some absolutely beautiful stuff along the coast there. And then last but certainly not least, we have Brent down in Texas doing some absolutely incredible. And those probably aren't even good enough words for what he's doing. So it's really great stuff. I encourage you to spend the afternoon, go through those videos, watch them. All my colleagues have something to offer. Certainly hope you got a little bit out of this today. And again, look for me on the Build Show Network. You can find me on Instagram at Stephen Basic Architect. And until next time, long live our buildings.